Welcome to Talk Tensors, where we unpack the most interesting and sometimes complex research in machine learning.
Glad to be here.
Today we're doing a deep dive into a really fascinating academic paper. It's called SurgRAW, Multi-Agent Workflow with Chain-of-Thought Reasoning for Surgical Intelligence.
SurgRAW. Sounds interesting.
Yeah, and what makes it particularly compelling, I think, is that it tackles a really tough nut to crack.
Which is?
How to reliably use these powerful vision language models, VLMs, in the super high stakes environment of surgery.
Ah, okay. Yeah, that's definitely a challenge.
The authors really pinpoint some critical limitations with current approaches. And their solution, this SurgRAW thing, well, it looks like a pretty significant step forward.
So the takeaway up front is that general AI, it really struggles with the nuances of surgery.
Exactly. It's just not built for that kind of critical environment.
That makes sense. I mean, we've seen amazing things with VLMs in everyday situations, right? Understanding pictures, text, but applying them directly to surgical intelligence. Yeah, you run into serious problems. You have to think about the precision needed, the deep understanding required in an OR.
Right. A general VLM might say, identify a tool.
Yeah, but is it definitely the right tool? Does it really get the procedure enough to know the implications of using that tool right then?
Good point.
And this paper highlights issues like hallucinations, that's a big one, where the AI confidently states something completely wrong.
Which is obviously a non-starter in surgery.
Absolutely unacceptable. Then there's the lack of specialized surgical knowledge baked into these general models. And the fact they often look at surgical tasks kind of individually in isolation. They miss the bigger picture, how everything connects in an operation.
Right. And that's where SurgRAW comes in, apparently.
Okay.
The researchers proposed this really innovative solution, a multi-agent system, and it uses chain of thought, or CUT reasoning.
Chain of thought. Okay.
So basically, instead of one AI assistant trying and maybe failing to do everything, SurgRAW creates like a specialized AI surgical team. Each agent focuses on its own expertise.
A team of AI specialists. Interesting.
And the CUT part is really key here. SurgRAW doesn't just spit out an answer.
It shows its work.
Exactly. It lays out its reasoning, which makes it way more transparent, more trustworthy.
Okay, I can see how that would be vital. The potential impact here for surgical intelligence seems huge.
You think so?
Definitely. Imagine an AI monitoring a surgery in real time, but offering genuinely nuanced insights and support to the actual surgical team.
That could really change things.
It could mean fewer errors, maybe more efficient procedures, better training for surgeons down the line, and ultimately, hopefully, better patient outcomes.
Yeah.
Just automating some aspects of understanding the surgical scene that could really revolutionize how surgery is done.
Okay, let's unpack this a bit more then. The paper starts by really drilling down on the limitations of just, throwing general VLMs at surgical problems.
Right.
We touched on the hallucinations, the lack of specific knowledge, but they also make a strong point about how these models treat each task, like identifying a scalpel or recognizing a stitch, as if it's totally separate.
Right, in a vacuum.
But real surgery, it's this carefully orchestrated sequence, isn't it? Everything's interconnected. Understanding those dependencies is absolutely crucial.
Precisely. And current VLMs often struggle with that interconnectedness. Another major hurdle the paper points out. It's just hard to train these massive models effectively for surgery.
How so?
Well, there just isn't the same flood of high quality, precisely annotated surgical data like you have for, common images or text.
Right. It's not like training on millions of cat pictures.
Exactly. It's specialized, complex stuff. And even existing chain of thought approaches where the AI tries to generate its own reasoning steps.
Yeah.
They can fall short in surgery because those self-generated steps often lack that deep grounding in specialized medical knowledge. They're reasoning, but maybe not like a surgeon would.
Okay. So what's the core idea behind SurgRAW then? Give us the high-level view.
So the central idea of SurgRAW is tackling these limitations by essentially creating a virtual surgical team.
Okay.
It's a multi-agent framework. Different specialized VLM agents are each responsible for specific tasks in the surgical workflow.
Got it.
And these agents are managed by a hierarchy of what they call orchestrators.
Orchestrators, like
Yeah.
conductors.
Kind of, yeah. And critically, each specialized agent uses task-specific chain of thought prompts to guide its reasoning.
Ah.
This really helps cut down on those unreliable hallucinations and make sure the reasoning is directly relevant to the surgical context.
A specialist approach that makes a lot of sense. Instead of one generalist AI trying to be an expert in everything surgical,
Right.
you have focused agents. And that chain of thought prompting is the key to making their reasoning clear, understandable.
Exactly. SurgRAW shows its work, as you said.
Nice.
But the framework actually goes even further. SurgRAW also incorporates something called Retrieval-Augmented Generation, RAG.
RAG. What's that?
Think of it like each AI agent having a sort of built-in search engine connected to a huge medical library.
Oh, okay.
This lets them access and incorporate external medical knowledge, bridging those domain expertise gaps we talked about.
That's clever.
And to make sure these different agents work together logically, consistently, they've put in a panel discussion mechanism
Panel discussion.
for AIs.
Yeah, where agents can interact and essentially, debate their findings and make sure they're all on the same page.
A virtual surgical huddle. That's actually a really neat way to think about it. Okay, let's get into the weeds a bit. How exactly is this multi-agent workflow organized?
So it uses that hierarchical orchestration we mentioned. At the very top, there's a department coordinator,
Okay, the boss.
kind of the initial point of contact for any question or query. Its main job is to classify the question. Is it visual semantic, like recognizing stuff in the video? Or is it cognitive inference needing deeper reasoning about the process?
Okay, triage. Exactly. Once it's classified, the query goes down to a secondary orchestrator, either the visual semantic department head or the cognitive inference department head.
Right.
These secondary orchestrators then take the query and direct it to the specific specialized agent best suited for that particular task.
And the paper focuses on 5 key surgical tasks,
Right.
each with its own agent. What are those roles?
Yes, 5 key ones. First, the instrument specialist. Pretty self-explanatory, identifies the tools being used.
Got it.
Then the action interpreter, which recognizes the ongoing surgical actions, the maneuvers.
Okay.
The action predictor tries to forecast the next likely step in the procedure.
Ooh, predictives.
Then the outcome analyst, which assesses the sort of goals of the current actions and predicts potential consequences.
Consequences.
Important.
And finally, there's the patient advocate. This one deals with extracting and understanding relevant patient-specific information from the context.
Patient advocate, that's actually a really interesting and thoughtful addition.
It is, isn't it? So each of these agents isn't just a generic VLM. It's a VLM tailored for its task and armed with that chain of thought prompting.
Precisely. They're effectively transforming these agents into code-embedded VLMs. And that's crucial because when an agent gives an answer or a prediction, it also lays out its step-by-step reasoning.
The transparency piece again.
Exactly. It makes it much more transparent, evidence-based, not just a black box result.
Right.
And for the visual semantic tasks, they also have a dedicated action evaluator agent.
Okay, what does that one do?
It plays a vital role in those panel discussions, specifically making sure the visual interpretations from the other agents are logically sound, consistent with the visual evidence.
That's a consistency checker.
You got it. And for the cognitive inference tasks, that's where the RA capability really shines. It lets those agents tap into that external medical knowledge to support their reasoning and recommendations.
Okay, let's zoom in on the chain of thought prompt generation.
Yeah.
How are these task-specific prompts actually designed? What kind of reasoning do they, guide?
Well, the researchers clearly put a lot of effort into designing these prompts to really mirror how a human surgeon might think through these different tasks.
Okay.
As we said, they're categorized visual semantic and cognitive inference.
Right.
For the visual semantic ones, like recognizing an action or identifying an instrument, the COTI prompts usually involve a pretty structured series of steps.
Like what?
Things like carefully analyzing the question first, then trying to pinpoint the target in the surgical image.
Okay.
Next, the agent extracts relevant contextual elements, maybe other objects, the environment for action recognition, or specific features like jaw shape, surface details for instrument recognition.
Gotcha.
Then it cross-checks these observations against the visual cues in the image, and finally it goes through this process of systematically eliminating the wrong options until it gets the most likely answer. It's very methodical.
So it's not just seeing, it's really visually analyzing and then logically deducing the answer. A structured process.
Exactly. Now, for the cognitive inference tasks, predicting the next action, assessing surgical outcome, understanding patient details, the reasoning steps are a bit different. More about the procedure flow and broader context.
How so?
These CUT prompts often start by breaking down the main question into smaller, more manageable parts.
Okay.
Then, the agent extracts relevant features, not just visually, but also conceptually. Things like which instruments are in play, what anatomy is being worked on, what's the overall stage of the surgery.
I see.
After that, the reasoning path kind of diverges based on the specific question. If it's predicting the next action, it's about understanding the current state and what usually follows in standard procedures.
Right.
For surgical outcome, it's evaluating the significance, the potential impact of current steps.
Wow.
And for patient details, it's pulling out relevant demographic or medical status info.
Makes sense.
And a really key part here for these cognitive tasks is the cross-referencing with the information retrieved through that RAG mechanism.
Bringing in the external knowledge.
Exactly, to make sure the reasoning lines up with established medical knowledge and to catch any potential contradictions.
Now, the paper also mentions expertise reinforcement through supplementary modules. What exactly are these add-ons? Sounds fancy.
Yeah. They're basically extra layers of checks and balances designed to boost the reliability and accuracy of the agent's reasoning even further.
Okay.
For the visual semantic tasks, the main supplementary module is that panel discussion we talked about, run by the action evaluator agent.
Trace the puddle.
Yeah. This evaluator uses a detailed knowledge graph. Think of it like a map of all the tools and actions the Da Vinci robot can do and which combinations are actually possible.
Based on the robot's specs.
Exactly. Derived from the robot specifications. This helps check if the identified instruments and actions are even logically permissible together.
Sure.
The evaluator also uses coherence rubrics, kind of like a grammar check for the AI's reasoning within its own task, ensuring a logical flow. And finally, it uses collaborative synergy rubrics to see how well the different agents' predictions reinforce each other. Basically, do the specialists on the virtual team agree?
So it catches inconsistencies early.
That's the idea. It's almost like a real-time peer review process among the AI agents themselves.
Wow. Okay. What about for the cognitive inference tasks? How is expertise reinforced there?
For those, the primary reinforcement method is that RGAB module. The Cognitive Inference Department head is responsible for querying a repository of trusted medical resources. They used Medline Plus in the study.
Okay, a reliable source.
Very. The information retrieved is then fed directly into the code-embedded agents. This lets them refine their outputs and make sure they align with established medical standards.
Which again helps reduce the chance of those hallucinations.
Precisely. It's about grounding their reasoning in a solid foundation of accepted medical knowledge.
Right. Okay, so it sounds like a really well thought out system. How did they actually test if SurgRAW works? They must have needed a solid benchmark.
They did indeed. And they actually introduced a brand new benchmark data set just for this called CERG-CUT Bench.
CERG-CUT Bench, okay.
It's specifically designed for reasoning in robotic-assisted surgery. Covers 12 patients, both prostatectomy and lobectomy procedures.
So different types of surgeries.
Yeah. And crucially, it includes detailed frame-level annotations for all 5 of those key surgical tasks we discussed. Gives a really comprehensive view of the whole workflow.
How big is this data set?
It's pretty substantial. Over 2,000 individual video frames and more than 14,000 question-answer pairs tied to those frames.
Wow.
And they created it very carefully. Sourced real surgical videos, extracted transcripts, downsampled the videos to key moments, then had experts annotate every frame with those 5 question types. Importantly, they also generated multiple choice questions for each task and had surgical experts manually validate them.
Sounds rigorous.
It does. And according to the paper, this is actually the first benchmark that covers all these critical surgical tasks within the context of the same surgical scenario.
So the data set itself is a contribution.
Absolutely. It's a real potential game changer for evaluating AI in a complete surgical context, setting a new standard.
Okay, so they have a benchmark. What were the actual results? How did SurgRAW stack up against other approaches?
The results were really quite compelling, actually. They compared SurgRAW against a few different baselines.
Like what?
Well, one was just querying a powerful general model like GPT-4o directly with the multiple choice questions from their benchmark.
Okay, the brute force approach.
Kind of. Another was using a lava coat prompt, which was a sort of leading method for generating chain of thought reasoning in VLMs at the time.
How did SurgRAW do?
It showed a really significant accuracy improvement overall, almost 30% better than just asking GPT-4o directly.
Wow, 30%.
Yeah, and over 22% better than using those advanced AlvaCoat prompts.
That's substantial.
It really is. And what's particularly noteworthy is SurgRAW's performance on those trickier cognitive inference tasks.
How did it do there?
It achieved a perfect 100% accuracy in understanding patient information.
Perfect. Seriously.
According to their results, yeah.
Yeah.
And a huge gain in predicting the next surgical action. Even in the visual semantic tasks, it showed clear improvements. The researchers also included qualitative examples in the paper, showing the very structured, logical explanations SurgRAW produces really highlights the explainability factor.
You can see the reasoning.
Exactly. They even compare it to surgical VQA, another leading method in the surgical visual question answering space, and SurgRAW outperformed it too.
Those are really impressive numbers. Definitely seems to validate their multi-agent COT-driven approach.
Did they do any ablation studies, taking parts away to see what matters most?
Yes, they did. They performed ablation studies, systematically removing or tweaking different parts of SurgRAW to see the effect on performance.
Okay.
They did this separately for cognitive inference and visual semantic tasks. For the cognitive side, they looked at the individual impact of just COT prompting and then COT plus RAG.
And what do they find? The results clearly showed that just using COT prompting significantly boosted performance on its own.
Right.
But combining RAG with COT led to the best overall results for those cognitive tasks. Suggests that having access to the knowledge is most effective when paired with structured reasoning.
Makes intuitive sense. What about the visual side?
For the visual semantic tasks, they looked at COT prompting and the panel discussion mechanism. Again, COT alone showed a big improvement. And adding the panel discussion further enhanced performance, especially for action recognition.
So the peer review helps there.
It indicates that having those collaborative consistency checks between the agents really does provide an extra benefit, particularly for interpreting actions correctly.
So it really seems like all the pieces, the multi-agent setup, the specific OT prompts, using RAG for knowledge, the panel discussion for consistency, they all genuinely work together synergistically.
Yeah, it looks that way. They combine to overcome the limits of just applying a general VLM to this really complex surgical understanding problem.
And that focus on explainability and reliability seems absolutely paramount for this kind of high-stakes application.
Couldn't agree more.
Now, let's maybe take a step back for a second, put this in context.
Yeah.
What's the sort of history here? How has AI in surgery evolved to get us to this point?
Yeah, it's interesting. AI in surgery has evolved quite a bit. Early approaches, years ago, tended to focus on developing very specific end-to-end models.
Narrow tasks.
Exactly. Things like automatically recognizing instruments or detecting specific errors or maybe identifying different phases of an operation.
Okay.
These models were sometimes effective for their specific job, but often lacked interpretability. They were kind of black boxes, gave you an answer, but not really the why.
Right, the explainability.
Precisely. More recently, with the huge leaps in large language models, LLMs, there's been this big shift towards trying to use their powerful reasoning capabilities for a more holistic understanding of surgical procedures. Vision language models, VLMs, which build on LLMs to understand both images and text, showed a lot of initial promise.
But as we discussed.
But as we've talked about, just applying these general VLMs directly to surgery revealed those significant limitations, hallucinations, lack of domain knowledge, context.
Got it.
So developing a framework like SurgRAW really represents a move towards more unified and crucially explainable AI systems for surgery.
So tackling the interpretability problems of older AI while still using the power of modern VLMs.
Exactly. But doing it in a much more structured, task-aware, and domain-informed way. Moving away from black boxes towards systems that can, at least to some extent, show their work.
Right, showing the reasoning is so critical in a field like surgery. Trust and understanding are non-negotiable.
Absolutely.
So just to kind of reiterate the core innovation here, It's really that smart combination of all these elements, isn't it?
Seems to be.
The multi-agent architecture mimicking surgical teams, the tailored coding prompts guiding specific reasoning, RA bringing in that vital external medical knowledge, and the panel discussion ensuring collaboration and consistency.
Yeah, that sums it up well.
It's this specific combination that really lets SurgRAW tackle the inherent weaknesses of just using general VLMs for the complex job of surgical understanding.
Mm-hmm. And that underlying focus on explainability and reliability is absolutely essential in this domain.
Totally agree.
And thinking about the potential real-world implications, the impact of a system like SurgRAW on actual surgical practice could be truly transformative.
How so? What do you envision?
Well, imagine surgeons getting enhanced decision support during an operation, almost like having a super experienced assistant constantly analyzing the scene, offering relevant, well-reasoned insights in real time.
That would be incredible.
It could also be an amazing tool for surgical training. Trainees could not only see what happened, but understand the detailed why behind each critical step.
Yeah, learning the reasoning.
Exactly. And while, fully autonomous robotic surgery is probably still a ways off.
Let's hope for now.
Yeah. But frameworks like SurgRAW could definitely pave the way for more advanced automation in the future. Always with that crucial element of patient safety and direct surgeon oversight, of course.
Of course.
Plus, that CERG-CUT Bench dataset they created, that's going to be a hugely valuable resource for the whole research community. It'll help drive more progress in this really important field.
It's genuinely exciting to think about the possibilities this kind of research unlocks. Now, as is our tradition here on Talk Tensors, let's shift gears into our Novel Notions segment.
All right, let's speculate a bit.
Where we explore some maybe slightly out there, but hopefully plausible new research ideas stemming from this work. What have you got for us?
Okay, so the first idea that kind of jumped out at me, thinking about SurgRAW, revolves around the concept of adaptive autonomy levels in surgical robots powered by a system like this.
Adaptive autonomy. Intriguing. Tell me more.
Imagine a system that doesn't just give info or suggestions, but could actually perform certain surgical tasks, but with varying degrees of autonomy.
Okay.
And this level of autonomy wouldn't be fixed. It would be dynamically adjusted based on how confident the SurgRAW multi-agent panel is in its own reasoning.
Confidence-based autonomy.
Yeah, and also based on how much agreement there is among the different agents.
Huh. How might that actually work in practice?
Well, you could picture a scenario, right? During a more routine, less complex part of a surgery, maybe closing an incision or something straightforward. If the SurgRAW system shows very high confidence scores, strong agreement among agents about what's happening and what needs doing, then maybe the robot could perform that task with greater autonomy, perhaps following a pre-planned path with minimal direct input.
Okay. But what about tricky situations?
Right. If the system hits a critical or ambiguous point like unexpected anatomy, a potential complication, this might show up as lower confidence scores or disagreement between agents. In that case, the system would automatically switch modes.
To what?
It would revert to only providing recommendations, requiring direct, explicit input and control from the human surgeon.
So it hands back control when things get uncertain.
Exactly. You could even link this dynamic autonomy adjustment to a real-time risk assessment that the agents are constantly generating based on the surgical scene analysis.
So it's a really dynamic, context-aware adjustment of the robot's role, shifting based on complexity and its own certainty.
Precisely. Think of it like a really advanced autopilot in a plane.
Oh.
It handles routine flight fine, but the second there's turbulence or something unexpected, bang, it disengages, pilot takes manual control.
That's a good analogy.
Of course, with surgery, the ethical side, the need for incredibly rigorous validation, testing before any clinical use, that would be absolutely paramount.
Massive hurdles there.
Huge. Ensuring patient safety. Making sure the surgeon always has ultimate authority and control. But the potential for boosting efficiency in routine parts while keeping human oversight for critical moments. It's an intriguing possibility.
It really is. Okay, what's your second novel notion building on SurgRAW?
My second idea explores potentially integrating patient-specific digital twins much more deeply with a framework like SurgRAW.
Digital twins. Explain.
Right now, the system mainly analyzes the live video feed from the cameras during surgery.
Okay.
But what if the SurgRAW agents also had access to a highly detailed preoperative digital twin of the specific patient on the table?
A virtual model of the patient.
Exactly, containing tons of info, their unique anatomy, pre-existing conditions, maybe detailed results from pre-op imaging, lab tests.
It seems like it would add a whole new layer of context, patient-specific context.
Precisely. Imagine the patient advocate agent, for instance, having direct access to detailed pre-op scans, their full medical history, latest blood work, all within this digital twin.
How would that help the other agent?
Well, this wealth of patient-specific info could then significantly inform the reasoning of all the other agents. For example, the action predictor might be able to anticipate challenges based on anatomical variations seen in the digital twin before they're even visible on camera.
Proactive prediction.
Yeah. Or the outcome analyst could maybe make much more accurate assessments of likely outcomes based on the patient's specific preoperative state documented in the twin.
So instead of just reacting to the live feed, the AI is constantly informed by a deep, individualized understanding of that specific patient.
Exactly. It would likely involve some serious research into how to effectively fuse that real-time visual data with the static but super detailed information from the digital twin.
How would you do that?
Maybe advanced attention mechanisms within the VLM architecture, allowing agents to prioritize the most relevant info from each source at different crucial moments in the procedure.
Sounds complex.
Oh, definitely. And of course, this kind of deep integration brings up major challenges around data privacy, security. You're dealing with incredibly sensitive patient info.
Huge ethical and logistical hurdles again.
Absolutely. But the potential payoff, truly personalized, proactive surgical planning and execution, it's enormous.
These are some incredibly thought-provoking ideas. Really highlights how a foundational framework like SurgRAW could be a springboard for even more advanced surgical intelligence systems down the road.
Absolutely. It's a real testament to the power of combining structured reasoning with collaborative AI to tackle these incredibly complex real-world challenges.
Well, this has been a truly fantastic deep dive into the SurgRAW paper. It's clear this research represents a really significant step forward in the quest to bring reliable, explainable AI into the operating room.
Agreed. It's promising work.
We definitely encourage our listeners to explore the research paper itself for a much more detailed understanding. As always, we'll put a link in the show notes.
Definitely worth a read if you're interested in this space.
And it really leaves us with a final provocative thought to chew on, doesn't it? As AI systems like SurgRAW get increasingly sophisticated at understanding these complex procedures, how will the traditional roles and responsibilities within the surgical team actually evolve?
Good question.
What new, maybe currently unimagined paradigms of human-machine collaboration will emerge in the OR of the future?
That's the multi-million-dollar question, isn't it? It's fascinating to think about.
Indeed. And just a quick reminder to everyone listening, our Novel Notions segment is purely for entertainment and sparking ideas. It represents speculative research concepts that may or may not ever happen.
Just some food for thought.
Exactly. Thanks so much for joining us on Talk Tensors for this deep dive.
My pleasure.
We'll catch you next time for another exploration into the fascinating world of machine learning research.